Now that we've put together a function to save a deck to a file, it's time to put together the opposite function, in which we will take a file off of our hard drive and then attempt to turn it back into an actual deck or a list of cards. So let's get to it. The first thing we need to do is review some documentation around that IOUtil package that we just used in the last video. So inside of here, there's another function that we're going to make use of now to read a file off of the hard drive, and it's very aptly named read file. So we can check out the documentation for it. We call read file, we specify the name of the file that we want to open as a string, and then in return, we are going to get back another byte slice and an error object. Now we'll talk a little bit about this error object in just a moment, but for right now, let's focus on the byte slice. Remember that whenever we see a byte slice, we want to think a string. So after we read a file off the hard drive, we're going to get back a string of characters, which essentially is the list of cards separated by commas. So it's going to be up to us to split that string by all the commas in between each card and then turn that back into an actual deck. So let's get to it. In my code editor, I'm going to create another function at the very bottom of the file. We're going to call this one new deck from file to very clearly indicate, hey, this is going to give you a deck from a file. Now again, we'll think about the function signature here a little bit. I don't think that we need any receiver to the function because, hey, we don't yet have a deck. If we're calling this thing, chances are it's because we want to get access to a deck. So I think that we need to pass in as an argument to the function the name of the file that we want to try to open and turn into a deck. And so let's receive that as an argument that we'll call file name, and we'll annotate that with type string. Now, after calling new deck from file, the expectation, without a doubt, is to receive back a deck. So I think that our return type here will be of type deck. Okay, so now we get to the fun part, where we're going to actually call that read file function right here. So again, note that we get back a byte slice and an error object whenever we call read file. So let's set up the function call. We'll say IOUtil, because that is the package that we are calling this read file function from. We'll say read file. We'll pass in the file name, which we received as an argument. And then remember, read file returns both the byte slice and an error if one occurred. So we've been through the process of receiving two separate arguments from a function already. Remember that we just list out the two variables that we want to assign these values to. So we will stick the byte slice that comes back from read file into a variable that we'll call BS, short for byte slice. And then the error object will assign to a variable that we'll call ERR, short for error. And then remember that these are truly variable initialization right here. So we have to use the : syntax for assignment. Okay, so we've now got the byte slice, which is the string of characters or string of cards separated by comma, and we've got the error object. So let's now talk about what this error object right here is. All right, I'm going to pull up a diagram. Here we go. Okay, so we just called read file, and we got back essentially our byte slice and an error object. So this is a value of type error. If something went wrong during the read file process, this error will be populated. In other words, there will be an actual value inside of it. But if everything went correctly with reading the file off the hard drive, then the value of error right here will be nil. So nil is a value in Go, which essentially means no value, or this thing has no value is contained within here. And so a very common pattern that we're going to see with a lot of Go code is immediately after getting back what might be an error object, so in other words, this might contain an error value or it might be nil, we'll usually put an if statement right after that and check to see if error is nil or not. So we'll say if error is not nil, then execute this code inside of here. By the way, I think this is the first time we've really seen an if statement, but like many other things with Go, it's just a regular if statement, really no difference from other programming languages that you're probably used to. So we place the if keyword, we put down the condition to check, and then a set of curly braces that are only executed, or all the code inside of here is only going to be executed if this statement evaluates to a true value. So inside of here is where we'll put together a little bit of error handling. So we're only going to get inside of here if an error was returned from the read file call. Otherwise, error will be nil and we'll skip entirely over this if statement. Now, error handling with Go is kind of a tricky beast because it really comes down to the very particular error that occurred to decide what to do here. For example, let's imagine that for some reason something went wrong during this read file call. Like maybe we tried to read a file that just does not exist on the hard drive. If that's the case, so if we got back absolutely nothing from the read file call, like byte slice is completely empty, I want to ask you the question here, what do you personally think our program should do? Like we call this function new deck from file, but we're saying that, hey, we cannot actually get a deck from this file. So what should we do in case something goes wrong here? Whenever you're trying to figure out how to handle an error with Go, I recommend that you kind of apply that very common sense question and just ask yourself, hey, if something goes wrong here, what do I really want to have happen? And so for me personally, I think that there's probably two possible options that we can do right here if something goes really, really wrong. Either we can say option number one, log the error, so essentially print it out and return a call to new deck. So this would kind of be option one. And this is just an option I'm throwing out there. I'm not saying it's the right choice. I'm just saying that it is one way we could take this. So if something goes wrong while we are reading a file off the hard drive, one thing that we could do is to print out the error that occurred so that we as developers know that something went wrong. But then to make sure that our new deck from file function still actually returns some usable deck, we could make a call to our new deck function, which you and I very well know will always return a deck. So in other words, we can kind of say here, well, if we fail to load a deck off the hard drive, let's at least give whoever calls this function a deck to actually work with. And so that's just one possible option. That's one way we could take this. Now the other option we could take is to say, you know what, if we are trying to read a deck from the hard drive and it just completely fails and we are not able to get it, that probably means that there's something extremely wrong with our program. And we should probably just assume that we don't want to do anything else and we should just entirely quit the program. So option two would be to log the error and entirely quit the program. So these are really our two options as far as I see it. Two ways that we can handle this error. Again, whenever you're handling errors with Go, I really recommend you just apply these kind of common sense questions of what you think the best thing to have happen is whenever something seems to go wrong. Now for us, I think that we'll take option number two right here. We're going to say that if something goes wrong with reading a file off the hard drive, that probably means that there's something just catastrophically wrong. Like we thought there was a deck there, we thought there was a deck with a given file name, but apparently there's not, something really bad is happening. So let's just say, hey, we couldn't load the file, we're done, get us out of here, quit the program. So we'll first console log, or not console log, but we'll print out the value of error right here so that we as developers know exactly what went wrong. And we can review it and say, oh, I guess we put in a bad file name or something like that. So we'll say fmt print line, and then we'll just pass in that error object. Now, a pattern that I really like to do is to put in error and then comma like so that we see the text error and it's just really clear, hey, here is an error that we're printing out. Now the actual error message will probably also say like, here is an error or something, but by putting in error colon, it just makes it really clear that, hey, here's an error message to review. And then immediately after that, we can exit the program entirely by making use of another Go standard library package called the OS package. And so we'll check out the documentation around it really quick. I'm going to go back to my documentation list. So here's all of our packages. And I'm going to search for the package OS. And there's a couple instances of OS. Here we go. So the description of this package is essentially platform independent interface to the operating system. And so no matter whether you are running your Go program on Windows, on a Linux distribution, or Mac OS, these are some functions that are going to work equally well across all those different operating systems. So if we scroll down to the index right here, you'll see that one of the possible functions we can call is exit. So if we call exit, by convention, if we call it and provide an argument of 0, that means that our program ran successfully. But if we pass in any value besides 0, that means that it will indicate that something went wrong while we were running the program. And so essentially, I think we can call this exit function, pass in an error code of like 1, and that will indicate that something went wrong with our program. So back inside of our code editor, we'll call os.exit and pass in the value of 1. Now remember, when you save the file inside of VS Code, OS is a package that we need to import, and so VS Code is going to take care of that import automatically for us at the top. But if you are using any other code editor, remember to put in the import statement for OS up here. Okay, so that pretty much handles our error handling case here. We're saying that if anything goes wrong while reading this file off the hard drive, hey, it must be a catastrophic error, let's log out what went wrong and then just quit the program entirely. Now after this, if we get past this case right here, that means that we must have successfully read something off the hard drive, and so we must have a value inside of this byte slice right here that we need to turn into an actual deck. So let's take a quick break. We'll continue in the next section, and we'll figure out exactly how we're going to take this byte slice and turn it into a deck. So I'll see you in just a minute.